Hey everyone, welcome back. Today we're diving into some applied statistics 101.
Yeah,
Think of it like your cheat sheet for your first year stats class.
that's right.
We've got a great summary from GradeGuru.
Yeah, it's packed with need-to-know concepts.
Oh, absolutely.
Yeah.
So we'll break down a couple of big ones for you today.
We'll be looking at decision trees
Okay.
and confidence intervals.
Okay, cool.
These are things that you will find yourself using way beyond the classroom.
Oh, absolutely.
Trust me.
Whether you're launching a business, analyzing research,
Yeah,
or even just trying to figure out your next move,
that's
right?
right. That's right.
These tools are going to come in handy.
Yeah.
Okay, let's kick things off with decision trees.
All right. So think of a decision tree as a visual map
Okay.
that helps you to make decisions when faced with uncertainty.
Mm,
It's all about breaking down a complex problem
right.
into smaller, manageable steps.
I like that.
Yeah.
A map for making tough calls.
Ex-
So our source uses the example of a company
Okay.
that's deciding whether to launch a new product.
Right.
They could see high demand, moderate demand, or low demand,
Uh-huh.
each with its own chances and potential profit or loss.
Right. And the decision tree lets you map out
Okay.
all those possibilities and their probabilities,
Uh-huh.
along with the potential payoff for each.
Okay.
This will help you to weigh the risks and rewards much more clearly.
Gotcha.
Yeah.
Okay, so in this example, the GradeGuru summary says
Okay.
there's a 50% chance of high demand.
Yeah.
With a profit of $50,000.
Right.
Then there's a 30% chance of moderate demand and a $20,000 profit.
Uh-huh.
And, of course, there's that chance of things not going so well.
Yeah.
20% chance of low demand,
Yeah.
leading to a $10,000 loss.
Exactly. But the real magic happens
Mhm.
when we use this information to calculate what we call expected profit.
Okay, so break that down for me.
Sure.
How do we get to that expected profit number?
It's all about the probabilities. You multiply the probability of each outcome by its potential profit or loss.
Okay,
So for high demand, we would take that 50% probability
right.
and multiply it by the $50,000 profit.
Okay,
That gives us $25,000.
got it.
Yeah,
And then we do the same for the moderate and low demand scenarios.
that is correct.
Yeah.
You would take the 30% probability of moderate demand and
Sure.
multiply it by $20,000.
Okay,
And finally,
right,
you take that 20% chance of low demand
right.
and multiply it by the potential $10,000 loss.
So then we add those three numbers up,
Yes,
and that gives us the overall expected profit.
precisely.
Okay.
Now, in our example from GradeGuru,
Yeah,
the expected profit turns out to be $29,000.
okay.
So this is telling the company, hey, if
Mhm.
you launch this product,
Yeah.
you can expect to make about $29,000 in profit
Wow.
on average,
Yeah.
taking into account all the possibilities.
So it doesn't guarantee success, but it's a way to weigh your options using data instead of just going with your gut.
That's right.
Right.
And that's what makes decision trees so valuable,
Yeah.
especially for businesses.
Hmm.
Think about venture capitalists deciding where to invest,
Oh, yeah.
or pharmaceutical companies deciding which drug to develop.
Wow.
They're constantly using these kinds of models to make smart choices under uncertainty.
But what about situations that are more complex than just a few possible outcomes?
Okay,
Do decision trees still work?
that's a great question.
Yeah.
And it brings up an important limitation of basic decision trees.
Oh,
They work really well when you have a clear set of outcomes and
Hmm.
probabilities.
right.
But in the real world, things can get way more complicated.
Oh, yeah.
You might have multiple layers of decisions,
Right.
constantly changing information,
Yeah.
or probabilities that are really hard to pin down.
So what happens then?
Okay.
Do we just throw the decision tree out the window?
Not necessarily.
Okay.
There are more advanced types of decision trees that can handle greater complexity.
Oh.
But it's important to understand the limitations of the basic model.
Mm-hmm.
Sometimes a decision tree can give you a false sense of certainty
Right.
if you're not careful.
Okay. That makes sense.
Yeah.
You're reminding us that even with these fancy statistical tools,
Yeah.
we still need to use our judgment
Right.
and be aware of the assumptions that we're making.
Exactly. Data can be incredibly powerful, but
Right.
it's just one piece of the puzzle.
All right, so we've tackled decision trees.
Yes.
Now let's shift gears a bit
Okay.
and talk about something called confidence intervals.
Okay.
I'll admit, this one always makes me think of
Okay.
Like those margin of error things that you hear in political polls?
You're on the right track.
Okay.
Remember, in statistics, we often work with samples of data
Okay.
to learn about a larger population.
Uh-huh.
Confidence intervals help us to understand
Yes.
how much uncertainty is involved when we use a sample. Right.
To estimate something about that whole population.
So, like, if we're trying to figure out the average height of all the students at our university, we can't possibly measure everyone.
Right.
We'd probably take a sample of students and measure their heights.
That's right.
Yeah.
And then we would use that sample average to estimate the average height of all students.
Okay.
But we know that our sample average might not be perfectly accurate.
Yeah.
It's just a best guess based on the students we happen to measure.
And that's where confidence intervals come in.
Yes.
To tell us how confident we can be in that best guess.
Exactly.
Okay.
A confidence interval gives us a range of values where we're pretty sure the true population average falls.
Okay.
And the level of pretty sure is determined by something called the confidence level.
So it's like saying we're 95% confident that the average height of all students is somewhere between 5 feet 5 inches and 5 feet 9 inches.
Yeah.
Rather than just saying,
we think the average height is 5 feet 7 inches.
That's a great way to put it.
Okay.
The confidence interval acknowledges that there's some uncertainty involved.
Yeah.
We're not claiming to know the exact answer, but we're giving ourselves a range where we're pretty sure the true answer lies.
Okay, so how do we actually calculate these magical confidence intervals?
The formula is pretty straightforward.
Okay.
Point estimate plus or minus the margin of error.
Okay.
The point estimate is our best guess based on the sample data.
Right.
In our height example, it's the average height of the students in our sample.
And then the margin of error is like a buffer on either side of that estimate, right?
Exactly.
It's saying, we could be off by this much.
That's right. The margin of error depends on two things.
Okay.
The standard error and the critical value.
Okay. Let's break those down one at a time.
All right.
What is the standard error?
Okay.
And what's so critical about the critical value?
The standard error measures how much our sample average is likely to vary from the true population average.
Right.
It basically tells us how spread out our data is.
Okay.
The bigger the standard error, the more spread out our data is, and the wider our confidence interval will be.
So a larger standard error means more uncertainty.
That's right.
Which makes sense.
Yeah.
But what about the critical value?
The critical value comes from a statistical table.
Okay.
And it's based on the confidence level we've chosen.
Okay.
The higher the confidence level, the larger the critical value, and the wider our confidence interval.
So if we want to be really, really sure that our interval contains the true population average, we would use a higher confidence level, which would give us a wider interval.
Exactly. It's a trade-off.
Right.
Higher confidence means a wider, less precise interval.
Gotcha.
Lower confidence means a narrower, more precise interval. But there's a higher risk that we will miss the true population average.
I'm starting to see how understanding these confidence intervals can be really useful when you're looking at data.
Absolutely.
Not just about the number itself. It's about understanding how much wiggle room there is around that number.
That's a really important insight. It's all about embracing the uncertainty inherent in working with data.
All right, let's walk through a specific example.
Okay.
I'm sure I got this down.
Sure.
In our GradeGuru summary, they give us a sample mean of 50, a standard deviation of 10, and a sample size of 100.
Okay.
And we want to calculate a 95% confidence interval.
Right.
What's our first step?
First, we need to calculate the standard error.
Okay.
Do you remember the formula for that?
Let me see.
Okay.
I think it's the standard deviation.
Yes.
Divided by the square root of the sample size.
That's right.
So in this case, it'd be 10.
Yeah.
Divided by the square root of 100.
Right.
Which is just 1.
Perfect.
Okay.
Now we need the critical value.
Yeah.
For a 95% confidence interval.
Right.
For a normal distribution, this value is 1.96.
Okay.
You can find this value in a statistical table, like Table D, in many textbooks.
Right.
Or even look it up online.
So now we have all the pieces of the puzzle.
Yes.
How do we put them together to get our confidence interval?
It's just like we said before.
Okay.
point estimate,
Uh-huh.
plus or minus, the margin of error.
Right.
The point estimate is our sample mean of 50.
Okay.
And the margin of error is the critical value,
right,
multiplied by the standard error, which is 1.96 times 1, or 1.96.
So our 95% confidence interval is 50 plus or minus 1.96?
That's right.
Which gives us a range from 48.04 to 51.96.
Right.
We're 95% confident that the true population mean falls somewhere between these two values.
Exactly. But here's where it gets really interesting.
Okay.
And where a lot of people get tripped up. That 95% confidence doesn't mean there's a 95% chance that the true mean is within this particular interval.
Wait, what?
Yeah.
I thought that was exactly what it meant.
It's a subtle but important distinction.
Okay.
Imagine you repeated this sampling process 100 times.
Okay.
Each time taking a new sample.
Yeah.
And calculating a new confidence interval.
Okay, so we'd have 100 different confidence intervals.
Yes.
All based on different samples from the same population.
Right. What a 95% confidence level really means is that on average, about 95 of those 100 intervals would contain the true population mean.
Okay.
It's about the long-run success rate of the method itself.
So it's not about the probability of a single interval being correct.
Right.
But about how often the method produces correct intervals.
Exact.
Over many, many trials.
It's a bit of a mind bender.
Right. But it's crucial to understand how to correctly interpret these confidence intervals.
Right.
They're telling us about the reliability of our estimation method.
Okay.
Not the probability of any single interval being right or wrong.
I think I'm starting to get it.
Good.
So confidence intervals are all about acknowledging that there's always some uncertainty when we're using a sample to estimate something about a larger population, and they give us a way to quantify that uncertainty and say how confident we are in our estimate.
That's a great way to sum it up.
Okay.
And understanding these concepts can help you to be a much more critical consumer of information.
Right.
Especially when you're bombarded with statistics, and news, or research articles.
Totally. It's like having a secret decoder ring for the world of data.
Exactly.
Now let's take a quick break.
Okay.
And then come back.
All right.
To unpack how all of this applies to real-life situations. All right, so we've covered the nuts and bolts of decision trees and confidence intervals.
Right.
But what does this all actually mean in the real world?
Right. Let's ditch the textbook.
Okay.
And see how these concepts play out in practical situations.
Okay.
How about those political polls I mentioned earlier?
Okay.
They always throw around those margin of error numbers.
Right.
What's the deal with those?
Well, that margin of error is directly related to the confidence interval.
Okay.
Remember, a poll takes a sample of voters and uses that to estimate how the entire population is likely to vote. The margin of error gives you a sense of how much uncertainty there is around that estimate.
So if a poll says candidate A is leading candidate B by 5 points, but the margin of error is plus or minus 3 points, what does that actually tell us?
It means the race could be much closer than it appears.
Why?
That 5-point lead would actually be anywhere between 2 and 8 points.
Okay.
Or even outside that range if we consider lower confidence levels.
Wow. Okay, so we have to be careful not to jump to conclusions.
Yes.
Based on just the headline numbers.
Right.
The margin of error gives us important context.
Exactly. It's a reminder that we're dealing with estimates based on samples, not absolute truth. And those estimates come with a certain level of uncertainty.
I'm starting to see how understanding confidence intervals can help us be more critical consumers of information.
Right.
Especially when it comes to things like election polls or scientific studies.
Absolutely. Let's say you're reading a news article about a study that claims a new drug is effective in treating a certain disease. How can confidence intervals help you evaluate that claim?
Well, I guess we'd want to look at the confidence interval for the drug's effect size.
Yes, exactly.
Is that what we call it?
The effect size is a measure of how much impact the drug has. And the confidence interval around that effect size tells us how certain the researchers are about their findings.
So if the confidence interval is narrow, that means they're pretty sure about the effect size.
Right.
But if it's wide, that suggests there's more uncertainty.
Precisely. A wide confidence interval might mean that the study didn't have enough participants.
Okay.
Or that the results were very variable.
Yeah.
It could even suggest that the effect of the drug is so small that it's hard to distinguish from random chance.
Okay, so a wide confidence interval could be a red flag.
Right.
Telling us to be more cautious about interpreting the results.
Exactly. It doesn't necessarily mean the drug isn't effective.
Okay.
But it suggests we need more evidence.
Right.
Before drawing firm conclusions.
This is all starting to click for me.
Good.
Confidence intervals aren't just some abstract statistical concept.
Yeah.
They're a practical tool.
That's right.
For understanding the limitations of data. And making informed decisions.
I'm glad to hear that.
Yeah.
And remember, these concepts apply to all sorts of data.
Okay.
Not just polls and studies.
Right.
Think about financial projections.
Okay.
Market research. Or even analyzing data.
Yeah.
From your own business.
So understanding decision trees and confidence intervals can actually make us better decision makers in all aspects of life.
Exactly. They help us weigh our options, assess risk, and make choices based on data rather than just gut feeling.
Right.
And they remind us that even with the best data and models, there's always some level of uncertainty.
Oh, okay, so as we wrap things up,
all right,
let's try to bring this all together.
Okay.
And give our listeners a clear takeaway.
Sure.
What are the key things they should remember about decision trees?
All right, starting with decision trees.
Okay.
They're incredibly useful for mapping out choices and their potential consequences when faced with uncertainty.
Right.
They help us to visualize the different paths we could take.
Right.
And calculate the expected value of each path.
Right.
Taking into account both the potential rewards and the risks.
But we also have to remember that decision trees are based on assumptions about probabilities.
Right.
And if those assumptions are wrong, the entire tree can lead us astray.
That's a crucial point.
Right.
We always need to be mindful of the limitations of our models and the quality of the data that we're using.
Right. Now moving on to confidence intervals.
Yes.
These are all about embracing the uncertainty.
That's right.
Inherent in working with data. Especially when we're using a sample to estimate something about a larger population.
The confidence interval gives us a range where we're pretty sure the true value lies. And that level of pretty sure
is determined by the confidence level we choose.
Remember, a higher confidence level means a wider interval.
That's right.
Less precise, but more likely to contain the true value.
Right.
Lower confidence level means a narrower, more precise interval. But there's a higher risk that we'll miss the mark.
It's all about finding the right balance between precision and certainty, which depends on the specific situation and the consequences of being wrong.
And the most important thing to remember is that a confidence interval isn't about the probability of that particular interval being correct, but rather about the long-term success rate of the method itself.
Exactly.
If we repeat this sampling process many times, the chosen confidence level tells us what percentage of those resulting intervals would contain the true population value.
I think you've got it.
Okay.
You're starting to think like a true statistician.
Well, I couldn't have done it without your expert guidance.
Well, thank you. Now, before we let our listeners go, I want to leave them with something to ponder.
All right.
We've talked a lot about how these statistical tools can help us make better decisions.
Right.
But they can also be used to manipulate or mislead. Think about all those ads you see with statistics like 9 out of 10 dentists recommend this toothpaste.
Right.
Or this investment strategy outperformed the market by 20%.
Yeah. Those claims might be technically true, but they often leave out important context, like the sample size, the methodology, or the confidence intervals around those numbers.
So someone could cherry pick data or use misleading visuals to make a product or idea seem more appealing than it really is.
Exactly. That's why understanding these statistical concepts is so important.
Yeah.
It's not just about crunching numbers.
Right.
It's about thinking critically, asking the right questions, and not taking things at face value.
It's about becoming savvy consumers of information.
Right.
Especially in a world where we're constantly bombarded with data.
Yeah.
From all directions.
You hit the nail on the head. It's easy to feel overwhelmed by all the statistics out there.
Right.
But by understanding the basics of how data is collected, analyzed, and presented, we can become more discerning and make more informed decisions.
So the next time you see a statistic that seems too good to be true, or an ad making bold claims based on data, remember what we talked about today. That's right. Think about the sample size, the methodology, and those all-important confidence intervals.
Ask yourself, what's the margin of error here? What information might be missing? And how confident can I really be in this claim?
Those are great questions to keep in mind. Data can be a powerful tool for understanding the world around us, but it can also be misused or misinterpreted.
It's up to us to be informed and critical consumers of information.
Well said.
Thank you.
And on that note,
I
think it's time for us to wrap up this deep dive.
All right.
It's been a fascinating journey into the world of applied statistics.
It has indeed.
Yeah.
And remember, this is just the beginning. There's a whole universe of statistical concepts and tools out there waiting to be explored.
So to our listeners, I encourage you to keep learning. Keep asking questions. And keep digging deeper. The more you understand about data, the more empowered you'll be to make informed decisions in all aspects of your life.
And remember, statistics doesn't have to be dry or intimidating. It can be a fascinating and even fun way to learn about the world around us. So embrace the uncertainty, challenge assumptions, and never stop exploring the power of data.
That's a great note to end on.
Well, thank you.
Until next time. Happy analyzing, everyone.